In this last lecture of network topologies, we are going to see two different types of topologies, that is point-to-point topology and point-to-multipoint topology. So let us first see what is point-to-point topology. You can see the image on the left hand side of the screen. Just focus on that for a few couple of minutes. Now, as its name implies, in a point-to-point topology, you have a direct connection between two routers or switches, giving you one communication path. The routers in a point-to-point topology can be linked by a serial cable, making it a physical network, or if they are located far apart and connected only via a circuit within a frame relay, it's a logical network instead. Now the figure on the screen illustrates three examples of typical T1 or wide area network point-to-point connection. What you see in the first part is a lightning bolt and a couple of round things with a bunch of arrows projecting from them, right? Well, the two round things radiating arrows represent our network's two routers, and that lightning bolt represents a WAN link. Now these symbols are industry standard and I'll be using them throughout this course, so it's a good idea to get used to them. Okay, so part 2 of the diagram on the left hand side shows two computers connected by a cable, a point-to-point link. Now by the way, this should remind you of something we just went over. Do you remember peer-to-peer networks that we had seen in earlier of this section? I hope you remember that. Good. Now I hope you also remember that a big drawback to peer-to-peer network sharing is that it's not very scalable. Now with this thing in mind, you probably won't be at all surprised that even if both the machines have a wireless point-to-point connection, this network still won't be scalable. You'll usually find point-to-point networks within many of today's wide area networks. And as you can see in the part 3 of the diagram on the left hand side, a link from a computer to a hub or a switch is also a valid point-to-point connection. A common version of this setup consists of a direct wireless link between two wireless bridges. Now just focus on the figure that is on the right hand side of the screen, that is point-to-point, that is point-to-multipoint topology. Again, as the name suggests, a point-to-multipoint topology consists of a succession of connections between an interface on one router and multiple destinations router. One point of connection to multiple points of connection. Now each of the routers and every one of the interfaces involved in the point-to-point connection are part of the same network. The figure on the right hand side shows a wide area network and demonstrates a point-to-multipoint network. You clearly see a cable, corporate router, connecting to multiple routers of the branch offices. That and the figure on the left hand side are the two different types of topologies that you need to remember. Now, a hybrid topology is a topology that is a combination of two or more physical or logical network topologies working together within the same network. Now, how to select the right topology? Now, you can just ask the question, well, we are just connecting cables between two hosts, so why do we need to actually think over this point? Wrong. Regardless of the type of the network you build, you need to start thinking about the quality at the bottom and work up. Now, I will give you a real life example and make sure you listen to it. Think of it as if you were at an electronics store buying the cable for your home theater system. You have already spent a bunch of time and money getting the right components to meet your needs. Now, because you've probably parted with a hefty chunk of change, you might be tempted to cut corners. But why would you stop now and connect all your high quality devices together with the cable equivalent of twine? No, you are smarter than that. You know that picking out the exact cables that will maximize the sound and the picture quality of your specific components can also protect them, right? It is the same thing when you are faced with selecting the physical media for a specific network. As you know, not only you have a buffet of network topologies to choose from, but each one has its pros and cons before implementing it. But it really comes down to that well-known advantage: ask the right questions. How much cache do you have? How much fault tolerance and security you really need? Also, is this network likely to grow like a weed? Will you need to quickly and easily reconfigure often? In other words, how scalable does your network need to be? For instance, if your challenge is to design a nice, cost effective solution that involves only a few computers in the room, getting a wireless access point and some wireless network cards is definitely your best way to go, because you won't need to part with the cache for a bunch of cabling, and that's super easy to set up. Now, let's say if you hired a person to design a network for an internet service provider running at 99.9% of the time, you need a Godzilla strength fault tolerance. So your primary solution is to either go with a hybrid or a partial mesh topology. Now again, remember that in mesh topology, there are a subset of n into bracket n minus 2 connections. So again, if you implement mesh topology, the cost will also go up. So here's a list of things to keep in mind when you're faced with coming up with the right topology for the right network. First question is, you need to ask, what is the cost of the installation? What is your budget? Do you have enough amount of money in your pocket to spend? The next question is ease of installation. Check the room, check the network size before selecting the topology. The next is ease of maintenance. Are you going to select a topology that is difficult to maintain? Absolutely not. You're going to select a topology that is a hell lot of easier to maintain. The fourth question that you need to ask is, what is the fault tolerance of the topology? Now, if you have around 10 to 15 computers and you select ring topology, then that's a bad call. Ring topology provides the least fault tolerance. So before selecting the right topology, you need to ask the question of fault tolerance. And finally, security requirements. Now, these 5 factors you should always consider before you select the right topology for your network. That's it, folks. This is all for the network topologies, and I hope you are learning a great content from this course.